So we're looking at a model overview here. So what we've got is we've got our intake structure here. You can see we've actually got the sheet piling, corrugation all simulated. The details out in the front, the intake, a lot of lights back there to see it a bit better on the back side. And then we've got a bit of the canal also simulated out here. So we put flow in and we're able to have some cross flow past it. It doesn't make much difference which way we go with cross flow or if we have any cross flow. Conditions at the pumps themselves are really set up with the expansion. So let's take a look at that. All right, so looking down from the top here, again, we were just standing on the other side. A quick shot of the overview here of the lab. We've got 4 large bays. This is one of them that you see here. These basins all share. So we're sharing with a discharge model over here is sharing yours. We'll put a dividing wall down the middle of it right here. So the sort of a multi-use. And that's why yours is it's got a bit of the canal out here, but the main portion of your model is looking down on it right here. The expansion, the flared walls on the side are really what set conditions up. No dividing walls down here. We've got a lot of flow separation as our water comes out these expansions right here, and that's creating significant pre-swirl. So we'll go down and take a look at that in a minute. Before we do, we're going to put a little bit of dye in up here. All right, so we're putting some dye down low. Let's watch that. It actually got upstream flow. See this? That water's going upstream and away from the pumps right here. That's the separation in the corner. Once we move in a little bit, we're going to go into this corner here. Watch this right here. So this circulation coming back away from the pump. What's happening is there's a large, we're going to move over to the right a little bit, right in here. We'll watch this. So you can see our flow comes in down the middle pretty straight towards this pump, and then it circulates around the back. So we'll come over to this corner over here, and you can see that dye's going upstream on this side over here. So it kind of pulls itself around right there. You see that circulation back up, and we'll watch it circulate around and feed the pump right there. So you can imagine that this happens at any kind of an expansion. This will occur. The flow comes straight in and it's circulating around the backside. So that's setting up a lot of swirl behind the pump. We're going to go down below and show you that. Okay, so if you take a look, see your rotometers are really spinning right here. If you take a look, they're just very, very fast. That's telling how much swirl we have. They're opposite. So 2 pumps are in one direction, 2 pumps the other. The center pump is relatively low when all 5 pumps are running. And the center pump is sort of straight in line anyway, and it's always a little bit better. We're going to come around behind the pump here. See this sideways flow again? We were talking about that it'll go down, then it'll go sideways here. That's that circulation around the back. It's creating a very, very strong floor vortex. You can see right here going up in. It's extremely organized. That's happening under all the pumps. It's contributing to the pre-swirl, but so is the circulation. The extent of which we're going to find out when we mitigate that. Let's go ahead into this corner here, and you kind of see that upstream flow from the backside here, going right up towards the front. You see it going right out. Stay back there. Right out the front. If you watch that. And then it wraps itself around to this pump. Let's go ahead and come over to the next one. We'll show you, we'll hit 3 of them here. There again, very, very well organized vortex activity. Let's go to the center pump. You see the same thing. So we don't know how much of this is due to the vortex activity or how much of it's due to the circulation. But this one's got strong vortex activity, but very little pre-swirl in that pump right now. So it's probably a combination of the two. We're going to go ahead and go to a, we've got mid-flow vortex activity also. Let's see if we can get into that. So this is a real, there it goes right, that's very difficult to get into these mid-flow vortices. You can see right, we're going to kind of just watch it for a moment. You'll see there'll be 2 vortexes going into each pump, or 1 going into each pump, 2 of them, and they form right in the center. The Daiwan breaks it up. You can see it just, if you watch closely looking for that circulation, you'll see it. We're going to try to get a good shot in it. It was there going good on the right. And try and get it where we can get there was kind of a bit of an on two of them. This mid-flow vortex activity there was a good shot right there. It's difficult to get rid of without dividing walls. So flow conditioning baskets are one of the things we're going to be looking at. They do attach to the pump. We've got to make sure that there's adequate screening, which we believe there is, to use those. They'll be very, very effective in this application. Let's go to a 4-pump. Okay, so 4 pumps here. Let's take a look at that. Okay, so 4 pumps running. Pre-swirl again just remains very, very high. Watch that just spinning right here. Let me get the value for that. And we're looking at the order of about 10 degrees on this pre-swirl, which is significant. The Hydraulic Institute will allow 5, and we try to be lower than that when possible. So we're double what's normally allowable. This can cause these pumps to really react in ways you're not anticipating. So we understand that one pump, particularly the last pump in the series, in the far end of the discharge header has vibration. The fact that there's very high pre-swirl could be contributing to that. Pre-swirl is in different directions. That may be having an impact on it. And the vortex activity as well. So let's go ahead and put a little bit of dye underneath here. Same vortex that you see, very well organized right there. We'll go ahead and put a little dye behind the pump. And you see again that same circulation back here behind that pump. Even with 4 pumps running, it's going all the way over to the sidewall right there. So 4 pumps, 5 pumps, very, very similar. We're going to go ahead now. Our thermometer is still quite high. Go ahead and put some dye underneath there and you'll see still get a well-organized, very, very strong floor vortex going up in here right there with that. We also get a little bit of surface vortex activity occasionally. It's not a significant problem here, but it is organizing. We'll go ahead and see. Sometimes we may need to let this go a little bit longer, but we'll see if we can get one to organize. Sometimes they'll come quite quickly and they'll be intermittent. They are organizing into type 3s, but they're not frequent. You can see a little bit of swirl trying to form. And this is low water level. We're going to let this organize a little bit. Okay. I think we're going to get one to organize here, it looks like. Again, they're forming. They're not a very high velocity core, but they are organized. You can see it going down here. It's working its way in. And it will get all the way to the pump, and it may break itself up. You can see it starting to, that ribbon will get itself down into there. This one here is going to decide to break up a little bit. They're not the big problem. The big problem here is the pre-swirl. We're going to look at flow conditioning baskets. We will look at a floor cone. The problem with a floor cone is it's not going to be very helpful against that mid-flow vortex, and it doesn't help against surface vortices. Again, these are somewhat infrequent, but they are organizing. All right, so we're going to watch one more form here. You see it just starting, that ribbon starting to go down. It's a type 2. It's just organizing into a type 3. You see it just going to get in. This one's going to make it down into the pump. There we go. Now it's going to tighten up a little bit, and you'll see that core will reach it all the way down in. And now that core is making it all the way up through, actually to the impeller location right here. You can see that. So they're not real frequent, and that looks bad. It's not a real strong one. The basket, flow conditioning basket, will chop that right up and dissipate it without any problem at all. So right now, since we've got all these issues without even having any cross flow, and we've got data showing that has a little impact, we're going to stop this video, and we're going to go ahead and put some flow conditioning baskets on and floor cone, and we'll come back and get a little more video of that. Witness test. So Scott Schutz is here from ITT, and our guys are helping. You've already seen a baseline video. Real quick overview of what we're showing him here. We've got flow conditioning baskets installed on 3 of the pumps. So these would attach to the suction bell. They can be installed in the dry outside of the wet well, or they could be attached to the floor. That detail can be sorted out. We're going to recommend attaching to the pump here. We've also looked at a floor cone, which would bolt to the floor. It's not as effective, and over here we have nothing. So as we saw in the baseline video, really high pre-swirl right here. Over here, if you'll notice, it still has pre-swirl. It's a little less intense, but it's bursty. It means it starts and stops. That's with the floor cone, so that's not very effective. And then over here, we just see very, very low pre-swirl, just a real low, steady, well under a degree. and that's fine. Let's go ahead and put the little bit of dye under this and show you again a quick summary. Strong floor vortex. Let's move over here to the floor cone. This is going to get rid of the floor vortex, but see this circulation and swirl that we've got still going around the side and the back of that? It's actually going to separate off the back of this vein right here and get right on the vein, and it'll spin off the back of it and go right up into there. So that circulation, that swirl that we've got, you can see it's going sideways, is still putting more water on that side, and that's leading to that increase in pre-swirl over here. Now let's go ahead and take a look at with the basket in place. You're going to see this flow just perfectly straight up underneath it as it goes up in. There's no rotation to that at all. You can see it on multiple grids. It's perfectly straight. And then up on the side, it stays attached to that throat all the way up in here. As we go around, there's no flow separation at all on that throat. You sit right there, you can see that. And just very, very low, very, very steady rotation. That rotometer looks like it might just be just a little bit crooked. And so that might even be why that's slowly rotating. Over on this one here, we've got nothing at all. You take a look at that one. You can see that dye just stays right attached. No rotation at all on that. So I think it looks like during the filling that one might have got just slightly out of bent right there, or out of round or plumbness. And then this one here, it's not moving at all. So the basket's very effective, dissipates the vortices, reduces the pre-swirl to well under a degree compared to this really unsteady, bursty starting and stopping over here. And this helps. As you can see, it's a lot faster, but it's not going to eliminate the vortex activity between them, and it doesn't eliminate pre-swirl low enough. Okay, just a little bit more video here. We're going to make note of a couple of things. So a second ago, we were running 20,000 GPM per pump, which was the rated design condition. We've dropped this down now to 60,000 total. We've got the same 4 pumps running, so this pump's now running at 15,000 GPM. You just see the rotometer's really still spinning. A little bit unsteady over here, and this one next to it. Over here, no pre-swirl at all, just a little bit in this one. There's still going to be one more round of final documentation testing where we're going to have the solution after we present it. We're anticipating the baskets on all 5 pumps, and then we'll collect data again. And then it gives us an opportunity also to get some of these additional test scenarios. For example, we'll get these 15,000 GPM 4-pump scenarios as well as 20, so we've got them both documented. But you can see pre-swirl remains very high. Same issue, we'll put the dye in, show you this still have strong floor vortex activity. So even whether you're running, you can see that. So it doesn't matter if it's backed up on the curve a little bit, it's still very, very adverse conditions on the pump. The pump itself will be a little more susceptible to this if it's back on the curve at 15,000 GPM or even 17,500. It's still going to like this vortex and pre-swirl even less than it does when it's at the rated flow at 20,000 GPM. But you can see the baskets still work extremely well on this end. So we'll be presenting all of this during a follow-up call with everybody attending that. All right, just one more test to show you here. We're at 17,670, so this would be 53,000 total with 3 pumps running. And notice your pre-swirl here again, and put some dye down there. You see that very strong floor vortex again here. No pre-swirl at all over on this pump. Right here. So we've got the same conditions at 15 all the way to 20 on our outer pumps, the 2 here and 2 here. Pump 1 is in line with that wall, so it's always pre-swirl has never been really high, but it may be a bit of oscillation. That's eliminated with the basket. So through the whole range we see the issue, and through the range it's all corrected. We're going to flip over this pump right here and turn on this one right now and show you that the basket works. Okay, so this pump's running, very high pre-swirl, and this outer pump's running, and it's just no pre-swirl at all, very, very low. So you can see they're symmetrical on the 2 sides. In the baseline video you'll saw they look identical, just different directions. The basket's very effective over this whole range of flow rates.